Welcome to this new episode of Insiders Insight. Today we're gonna talk about wireless charging. So as one of the few guys, I guess, in the world that know wireless charging the best, let me give you some insight of how wireless charging works, cell phones, and what kind of wireless charging product features that you're dealing with, and what is the difference between charging technologies out there nowadays. Let's start it with some basic knowledge here. There's no good definition for wireless charging. Wireless charging is basically, you can imagine there's no electrical contact between the chargers to your device. So typically we call the device that is sending the power or the power source as a transmitter, and the device that receiving the power we call receiver, or usually we call transmitter TX, receiver RX. So the most popular wireless charging technology will be WPC-Qi wireless charging. So all the cell phones, the very popular cell phone that people are using, like iPhone, Samsung phones, Huawei phones, including also Xiaomi phones, as well as Google Pixel phones. So everybody in the phone market are adopting Qi wireless charging. So Qi wireless charging is basically an inductive coupling system that is very similar to a normal transformer. However, it's not like a transformer that has a closed structure that you have magnetic cords to sort of shape or shunt the magnetic field that go through the windings. So in wireless charging case, the magnetic field is actually going through the air or air gap between the RS and TX, and hopefully most of the magnetic field sent from the transmitter will be received by the receiver. So usually we call it loose or loosely coupled system, because it's the coupling coefficient that we're dealing with in a wireless charger is typically around between 0.5 to 0.8. Another type of wireless charging technology we usually call resonance type wireless charging, which is even loosely coupled than the Qi wireless charging. What we are saying before was that for Qi wireless charging, the coupling between primary side and secondary side is around 0.5 to 0.8, but for resonance type is definitely lower than usually 0.1. So you can imagine that a lot of field that is a leakage field that's sending from the transmitter, which is not get received by the receiver. So that means the usually the transmitting efficiency or the receiving efficiency is quite low compared with the Qi wireless charging. However, the good thing is for resonant type is that you can have pretty good receiving distance, which is usually around 10 millimeter to like 10 centimeter range. However, as I said, it's a trade-off, so it's a purely physics, right? So the more distance you have, the less energy that you're gonna couple. So people are trying to solve this problem by making the coil much bigger, so that you can have a bigger coupling area, and also improve the efficiency while you have a longer distance. However, such a big coil on the receiver or transmitter side usually is not very practical for a consumer electronic device such as a cell phone. Usually that coil may not be able to fit in either XY dimension or Z dimension. There are other type of wireless charging as well, which is further down the road, which is very similar to the cellular or the high frequency or the radio frequency technology that we're using for cell phones and other things. So what happens is you may end up with which is called far field charging. It's nothing but you have a very high frequency transmitter that's sending the RF signal through the air, and the receiving device try to use a sort of high frequency antenna to receive that. So which is typically the receiving power is in the range of like milliwatt range, which is typically not enough for using your cell phone. There is a very important concept that you have to understand. All of the wireless chargers have to have this feature we call foreign object detection, which is nothing but detect a friendly metal in the middle of the surface between a transmitter and the receiver. If you do not have this detection mechanism, what's gonna happen is you may end up with having a coin between your transmitter and your phone, and then even though your phone may still receive power, however the coin will be heat up, and then you may burn your finger that way, or even in the worst case you may catch fire.